Okay, good morning. Welcome to
FamilyMath number 1101.
FamilyMath 1101. So our friend Dylan Berger made this really neat GIF to play around with, but before we even start playing around with it, what do you think's going on with it?
I'm not sure. It looks like there's a circle that's moving around, and it looks like it's blue if it's in this sort of quarter circle area in the square, and then it looks like it's green if it's outside.
Okay.
So I guess maybe this has area pi, or maybe it's like a 2x2 square, and then we're just like choosing random points and seeing how many are in and how many are out.
Okay. So he says pause the video and then answer the poll in the thread.
Alright, let's pause it.
Okay.
So he paused it, and it looks like it's more purple than blue, but
That's fine. When you pause the video, so I had already answered the poll, so but it's fine. When you pause the video, where was the dot? Let me zoom in.
so it was inside the circle for us.
Uh-huh.
So the ratio of the area of the square and the circle is pi over 4, which is what I thought it was. I thought it was a 2x2 square, and it's a quarter circle's area pi, and the square is area 4.
Okay.
Culmination of the dots that fall inside the circle is the circle's area. That makes sense, and the number of dots in the square, or number of all dots, is the square's area.
Uh-huh.
So, and the votes are a little bit of area approximated by that small circle. So the approximation is pi over 4.
All right, well, let's check. There's a calculator, actually. We're using that phone over there for the calculator. What is pi over 4?
It's about 78.5.
Okay, and so we're getting 79.5 in this simulation, or at least as of now with, what was it, 17,000 votes? And we got it inside the circle. So what do you think of that approximation?
I mean, it's a pretty good approximation for just kind of a rough test. I mean, I don't know how the circles are distributed, and maybe there's some explanation for why it's a little bit more, but it's a pretty good approximation for just kind of randomly.
All right, well, let's run it and
points.
see if we get roughly 1 in 5 outside the circle.
All right.
So why don't you just, I'll turn it back on, but like close your eyes and then stop it.
All right. Let's stop it here.
All right.
In.
Okay.
Stop it here. In again.
All right, so we're 3 for 3.
In again. In again.
Uh-oh. Is that 6 now?
6, yeah.
7?
8.
9? I don't know, by now we should have had about 2 for the 10th one. Still got 0. Huh, I wonder how long it's going to go. 11.
Oh, there we go.
Alright, nice. So it took 12 tries, but okay, so that's fine. So what do you think of this as a simulation or an idea, doing this on Twitter like this?
It's kind of an interesting idea. It's, I guess, kind of a new way to approximate pi. You basically just take like little circles, and you're taking 30 seconds worth, and there's 1 per frame of this video. So I don't actually know how many that is. If it's 60 frames per second, maybe 30 frames per second, but you're taking a lot of little circles and you're basically just reassigning them random coordinates in this square, and then you can see how many of them are in here versus how many, because you think, I mean, you know the area of this shape, so you think you know what you expect. But I mean, maybe for a shape that you wouldn't know the area of, like if you just kind of drew a blob in here.
Oh yeah, that's a very good idea. This would be if there was a shape that we didn't necessarily know a formula for, or even like any kind of formula for the boundary, because maybe if we somehow knew even a complicated formula, we could use calculus. But if we just drew a shape and then did this kind of simulating, we could find its area. Yeah, that's a good idea.
Yeah.
Okay, I really like this. I thought this was real fun, and it's cool that he's had more than 17,000 people participate.
Yeah.
And you know, we didn't get. It's not like we got pi to 5 decimals, but we got something close.
Yeah.
So it's cool. All right, good job, hon.